That all her dreams would come true. She was only 7.
Hi, I'm Alya. I'm Nani. Today, we are going to tell you what is related rates and also why we use related rates and application related rates in our daily life. So let's check it out. Related rates involving finding a rate which quantity changes by relating that quantity to other quantities whose rates of change and the rate change usually with respect to time. Okay, why we use related rates? It is because science and engineering are related to each other. The methods of related rates have broad applications in these fields and in our daily life. Application in our daily life is when a balloon is filled with air, both radius and volume is increasing. So we know the rate of changes in radius and also volume. A glass filled with water is shown in figure 1. Water is flowing into glass. When the depth of the water is h cm, the volume of water v cm cube is given by V equal to 4 pi h, h plus 4. Water flows into the glass at a constant rate of 40 pi cm cube as negative 1. Find the rate of the change of the depth of the water in cm as negative 1 when h is 5.
So based on the formula, we rewrite the formula which is V equal to 4 pi h, h plus 4. Then we expand the formula, become 4 pi h square plus 16 pi h. Then we differentiate the last formula, become 8 pi h plus 16 pi. Based on the formula, we need dh per dv. So we take dv per dh and we turn into dh per dv equal 1 over 8 pi h plus 2.
Based on the question, we need to find dh over dt. dh over dt equal to dh over dv times dv over dt. dh over dt equal to 1 over 8 pi h plus 2 times 40 pi. Then we solve it. 40 becomes 5 and 8 pi becomes 1. So dh dt equal to 5 over h plus 2. When h is 5, dh dt equal to 5 over 5 plus 2. dh dt equal to 5 over 7. And the final answer is 0.71 cm per second. That's all.
Hi, it's Anis, and me and my friend Izwan are going to explain the second problem of related rates, which is the ladder problem. Let's go. So from the question, we can gather that our dx over dt equals to 1, and that we have to look for dy over dt. So, looking at the picture on the right, you can see that it forms a triangle, and that means we can use the Pythagoras theorem. That will give us x squared plus y squared equals to 10 squared, which will give us the result of x squared plus y squared equals to 100. Next, we're going to differentiate this equation in respect to time using the chain rule, and that will give us 2x multiplies with dx over dt plus 2y multiplies with dy over dt equals to 0. Next, to find only dy over dt, we will have to move the unrelated terms to the right. So that will give us 2y multiplies with dy over dt equals to negative 2x multiplies with dx over dt. Next, we will have to divide negative 2x with 2y. That will give us dy over dt equals to negative 2x over 2y multiplies with dx over dt. Lastly, we will get the result of dy over dt equals to negative x over y multiplies with dx over dt.
Then, to find the dy over the dt when x equal to 6, first, you guys need to rewrite back the equation x squared plus y squared equal to 100, but replace x with 6. Then bring 6 squared to the right sides. Then minus 100 with 6 squared will get 64. Next, square root 64 will get y equal to x. Then, to find the value of dy over dt, it will be negative 6 over x multiply with 1. Then you simplify, it will get negative 3 over 4. And that is the final answer. Hi guys! So for this part, who actually the last part for this video, I'm going to complete to all of you about this topic, and I want to give you information about the advantages and benefit from this topic. Related rates problem involve finding a rate at which a quantity to other quantities whose rate of change are known. The rate of change is usually with respect to a time. So why we should learn about this topic, which is related rate? Why? First, why we should learn about this topic, because science and engineering often relate quantities to each other. The method of related rates have a broad application in these fields. Okay, differentiation with respect to a time or one of the other variables require application of the chain rule, since most problems involve several variables. So just now we have seen quite a few related rate problems. There are still many different kind of related rate problem out there. Should give you a pretty good idea on how to at least type most of the problem that you are about to run into. So I hope with this video you guys can just do like reference for your question that you really didn't know about that. So I hope this video kind of helped for you guys. So don't forget to give us a thumbs up for this video. See you for next video. Thank you guys. Bye.
Would come true. She was only